Hi everyone, I hope you are doing good. Have a great day. Myself Ramraj B, Assistant Professor, Department of EEE, Nanda Engineering College. So today in this video we are going to see the basic types of signals and systems. Right? So before going into the types, we'll just discuss basic we'll get a basic knowledge about signals and systems. Then finally we'll touch the major types of signals and systems. So wherever we go, whatever we do, right, we involve some kind of system to process our work, and the input to that particular system and the output of that particular system will be a kind of signal, right, which will be given as input, and the desired output will be what we need, right? So basically a signal is classified into two types. One is continuous signal, the another one is discrete signal, right? Before that, the basic definition for a signal is a physical quantity which depends on time or representing with respect to time is known as signal, right? The signal will be always represented with the help of x of t, which will be the input signal, right? And the y of t is the output for the corresponding input signal, right? So the signal is classified into two types. One is continuous, the other one is discrete. The continuous signal will be in the form, let us assume a sinusoidal signal, for example, to denote continuous signal, right? Either V or I in y axis, right? In x axis we have taken TS reference. So this signal is known as continuous signal. A continuous signal can otherwise be defined as the signal will have a common time period, right? Or the signal will have same time period, same interval of time, right? Let us assume that it is one complete clock cycle. So positive will have 2 seconds to complete the positive cycle, and the negative cycle it will take 2 seconds to complete it negative cycle. So totally 4 seconds to complete one complete cycle. It takes 4 seconds. Similarly, the next pattern of this signal will have 2 seconds for positive and 2 seconds for negative. Again 4 seconds. Similarly, the repetition of the same pattern denotes the signal is a continuous signal. There will not be any breakage in the signal, right? There will not be any breakage, there will not be any discontinuities in the signal, right? If it is like this, then the signal is known as continuous signal. This continuous signal is again classified into even signal, odd signal, even signal and odd signal, right? Actually, we will be seeing this in terms of symmetry, even symmetry and odd symmetry, right? Even we have off-phase symmetry, right? These are the kind of symmetries, right? Which will be we will be seeing these symmetries in next video, right? Now we'll have a basic idea of continuous signal and discrete signal, right? And systems, right? So yes, continuous signal will have a continuous data in a signal with respect to time, and whenever you pick the signal or whenever you need some data with respect to time at particular time interval, you can easily pick this data, right? Because this is a continuous signal, right? So it will have a common clock pulse and the common clock pulse or the common time period will be repeating for all continuous pattern, right? Either in negative side or in positive side, whatever it may be, right? So this is continuous, right? The discrete signal will be in the form and this is the example for discrete signal, right? V and I, this is T in x-axis. Now look at here. So at T is equal to 0, the signal is 0, and at T is equal to 1, let us assume the time interval 6, 7, 8, 9, etc. So when T is equal to 1 second, the amplitude is 1 volt, and when T is equal to 2 seconds, the amplitude is 2 volt, and when T is equal to 3 seconds, the amplitude again decreases to 1 volt, and when T is equal to 4 seconds, the amplitude is minus 1 volt, when T is equal to 5 seconds, the amplitude is minus 2 volt, and when T is equal to 6 seconds, the amplitude is again minus 1 volt. So the maximum value is plus 2 volt and the minimum magnitude or amplitude value is minus 2 volt, right? So with respect to time, at each and every instant of time interval, at t is equal to 1 or t is equal to 2 or t is equal to 3, at any interval of time, we can define the particular amplitude or magnitude of the signal, 1 volt, 2 volt, 3 volt, etc., right? But in continuous signal, we'll have a continuous waveform, but in discrete signal, we'll have a pulsated waveform, discrete pulse waveform, right? So this is known as discrete signal. This characteristics or this form of signal is known as discrete signal, this form of signal is known as continuous signal, right? So this is the basic classification between this continuous and discrete signal, right? Now we will see the importance of before seeing to the importance of the discrete signal, right? The best example for this discrete signal is sampled signal, which will be applied in AM, amplitude modulation and frequency modulation, right? We will be applying the sample signal in amplitude modulation, frequency modulation, right? So these are the two basic kind of signal. Next we will see a system, right? Next we will see a system. We will see a system. So the definition for a system is, let us assume a box with one input and one output. The input to the box is x of t and the output from the box is y of t, and this is system. The system may be of, right, any functional device. The system may be of any functional device, whatever may be, right? Let us assume that the system is a pen, right? Pen is the best example for a system, right? System. Now the input for the pen is x of t and the output for the pen is y of t. The input for the pen is ink, and the output of the pen is y of t. The output, desired output is letters, writing. We will be writing the pen, writing the letters through the pen, right? This is the output, right? So the input is x of t. It is processing, the system is processing, the pen is processing processing the ink, and it is producing an output in paper with the help of letters, right, which is y of t, right? So this is system, right? There are different kind of systems. Bounded input, bounded output system, right, is one best type of system. Bounded input and bounded output means the system will have a predefined input and predefined output, right? we will have a few other system which will have bounded input but different output, right? We cannot define the outputs, right? For example, bounded input means we will have 5 input, and the bounded output means we will have 5 output, right? If it follows before, then we will have 5 input and 5 output, for example, right? Or 10 input or 10 output, for example. The output will be based depend upon the input, but in bounded input, in other category, we will have bounded input but different output, right? In that category, we will have 5 input and we will have many outputs, or outputs less than the number of inputs, right? So this is the basic definition for the system. I will give one more definition, one more example for the system, right? Again, x of t as an input for system and y of t is the output for the system. Here, let us assume a keyboard, right? Here I am giving typing a letter A, right? This is the input for the keyboard, and the keyboard will process the A. I mean the keyboard will recognize the letter which I typed on the keyboard, pressed on the keyboard, right? So it will recognize the key which I have pressed, and then it will process the output in the screen, monitor screen, as A, right? And this is my y of t, right? This is the best example for systems. Now the system is again classified into, with respect to feedback system, which is open loop feedback system and closed loop feedback system, right? If a system which has one input and one output, then it is known as open loop feedback system. This system is known as open loop feedback system, right? This is the best example for open loop feedback. It will give, if you give some input, it will produce some output, right? This is the best example for open loop. Then we have one more type, system, and this is y of t output, and this x of t input. Here the output of the system will be used as a feedback to the input of the system. The same system will have the output as input, right? So now see here. So I am giving x of t as input to the system. It is processing some processing x of t input signal and producing output y of t, and the same output is again fed as input to the system, right? So again, this x of t and this feedback will act as input to the new system, and it will produce a corresponding output which will be given to y of t, and again the same will be, this kind of iterations will be repeated until we get desired output, right? Until we get desired output. We'll have for some application we need a system without feedback loop. For some system we need for some application we need some system with feedback loop, right? So the best example for this is keyboard, fan, light. These are the example for the system without feedback, and example for the system with the feedback is washing machine, refrigerator, air conditioner. These are the best example. Microwave oven, traffic light controller. These are the best example for temperature controller. These are the best example for feedback loop system, right? Let us consider an air conditioner. When the temperature of the room temperature is let us assume that we set 18 degrees Celsius in our room, and if the temperature increases, the air conditioner will sense the temperature, and now if the temperature is previously I have set the temperature 18 degree, but compressor will shut down after getting this 18 degree, and now the room temperature is getting increased. Now the temperature is 22 degrees Celsius. Now the sensor will activated, and the air conditioner sensor will get activated, and it will sense the temperature. Now it is 22 degrees Celsius, and the feedback loop will be acting here, right? Now the system is air conditioner, and with the help of the sensor, it sensed the temperature, current temperature as 22 degrees Celsius. Now the temperature which I have set in the room should be around 18 degrees Celsius. Now the air conditioner will turn on the compressor, and the compressor will turn on, and it will cool the room to 80 degrees Celsius. When it reaches 18 degrees Celsius from 22 degrees Celsius, automatically the air conditioner compressor will be shut down, right? This complete process will be happened with the help of this feedback loop system, right? This is the best example for feedback loop system, right? So this is the small introduction about system. Now we'll see the types of signal and types of system. We'll see the basic types and basic types of system, right? Basic types of signal. Types of signal. First one, linear and non-linear signal. Second one, unit step signal. Third one, ramp signal. Fourth one, parabolic signal. Fifth one, impulse signal. So these are the basic signals that will be used in real-time applications, right? Linear signal, non-linear signal, unit step signal, ramp signal, parabolic signal, and impulse signal. So in next video we'll see the individual definitions of this signals, right? Now let us go for types of systems. The first one is causal system, causal and non-causal system. Second one, linear time variant system and linear time invariant systems. Next one, linear and non-linear systems. Next one, stable and unstable systems. So these are all the basic types of systems, right? So in this class we have seen the definition for signal, systems, and examples for signals and systems, and types of signal and types of systems. So